Today we're going to learn how to balance chemical equations, and we're going to get lots of practice at this. So I want you to make sure that you have a pencil and a piece of paper in front of you, because I'm going to give you a chance to try some of these yourself, and then we'll check to see if they're right. So make sure that you've got that in front of you so that you're able to try these right along with me. We'll start out by looking at a couple of the equations that I had on the board yesterday where we said they weren't balanced, and we'll see if we can figure out how to balance them. So the first one was this hydrogen chloride plus calcium yields calcium chloride plus hydrogen. Now, if you recall, we said that hydrogen is one of those elements that always has to have two of them hooked together. So that's why this 2 is here. And if you remember, again, from when we were writing formulas, we said that the calcium is in that column where it always has a positive 2 charge, and the chlorine is in a column where it always has a negative 1 charge, and so I have to have 2 negative 1 charges to balance out that positive 2 charge. So just a little bit of review from what we were doing in the last chapter so that you recall why these subscripts are here to begin with. Chlorine was -1, hydrogen was +1, so I just need one of each to make those charges balance. The reason I wanted to remind you of that is because, like I alluded to yesterday, when I go to balance a chemical equation, I can't change any subscripts. So it's almost as if I have boxes around these guys and I can't go in and change any of the subscripts. The boxes are closed and they are sealed, and the only way that I can balance the equation is to put a coefficient in the front if it isn't balanced, okay? So let's look at what I have on each side and see what I need to do to get it balanced. So on this side, I have 1 hydrogen. How many are on the other side? Yep, there are 2. So in order to balance the hydrogen, I can put a 2 in front of the HCl. Okay, so now my hydrogens are balanced. What about the calcium? Is it balanced? Well, I'm sorry, not the calcium, the chlorine. I have 2 chlorines here, and because there's a subscript of 2 by this chlorine, I have 2 chlorines on the other side. So the chlorine is balanced. What about the calcium? I have 1 on this side, and I have 1 on this side. So the calcium is balanced. So all I had to do to balance this equation was to put a 2 in front of this, and that gets the whole thing taken care of. Okay? Let's look at the second one. This again is another one that we had from yesterday where we looked at it and we said, no, this one isn't balanced because there's 1 calcium on each side and there's 1 sulfur on each side, and there's 2 oxygens here but only 1 over here. Now, what you might be really tempted to do, and hear me carefully on this, you might be really tempted to go over here and just stick a 2 there and go, there, it's balanced. Oh, but you can't do that. You can't ever add a subscript because what have you done? Well, remember, this calcium has a positive 2 charge. This oxygen has a negative 2 charge. I can't go messing with those subscripts anymore. So it's just like I drew up here. There's a box around that. It's an invisible box, and you can't go in and change those subscripts. The only way to balance is to change the coefficient in front of the chemical formula. So let's see what I need to do. So as I've already said, the calcium is balanced, the sulfur is balanced, the oxygen is not. So if I have 2 oxygens here, then I'm going to have 2 over here. But when I put that 2 there, what happened? Well, now I not only have 2 oxygens, but I also have 2 calciums. So that means that my calciums now are not balanced, so I'm going to have to come over here and I'm going to have to put a 2 in front of this to make my calciums balanced. Well, now what did I do? Well, now I have 2 sulfurs. And so now my sulfurs aren't balanced. So if I have 2 sulfurs here, I'm going to need 2 sulfurs on this side as well. Okay, did I get it? Always want to make sure you go back and check once you're done adding coefficients and make sure that you actually got to where you thought you were getting to. So I have 2 calciums here. I have 2 calciums here. I have 2 sulfurs here, I have 2 sulfurs over here, I have 2 oxygens on this side, and I have 2 oxygens on that side. So this equation is now balanced. All right. Now we're going to check out this equation right here. I want you to notice that we have to going to be a little extra careful on this one, because while I have my sodium, my hydrogen, my oxygen that I'm going to have to check and see if they're balanced or not, my hydrogen is located in two different places on this side. So when I check to see if my hydrogen's balanced, I've got to look at both of those and add them up to make sure that it's going to come out right. Okay, so I have sodium. The sodium, I have one on each side, so it looks okay. Hydrogen, I have two on this side, but I have one here and two here, which makes a total of 3. So I have more hydrogen here than I do on this side. So it would be nice if I could just erase that 2 and make it a 3, right? But I can't do that, because remember, we can't change the subscripts. So the only way that I can get more hydrogen on this side is to make this a 2 in place of a 1. There's really a 1 there, it's just invisible. So now how many hydrogens do I have? Well, I have 4, but how many did I have on that side? Well, I had 2 here and I had 1 here. So what am I going to do to make it 4? Well, if I put a 2 in front of this, that's going to give me 2 hydrogens here and 2 hydrogens here for a total of 4 to match the 4 hydrogens that I had here. So now let's check the oxygens. I have 2 oxygens on this side, and I have 2 oxygens on this side, and I should be done, right? I don't think so, because when I put this 2 in front of here, that also affected my sodium. So now that I have 2 sodiums here, I'm going to have to go add 2 over here. So let's go through and let's make sure that I have everything balanced now. 2 sodiums on this side, 2 on this side. I have 2 times 2 is 4 hydrogens on this side, and I have 2 hydrogens here and 2 hydrogens here for a total of 4. I have 2 oxygens here and 2 oxygens here for a total of 2 on each side, and so that makes this equation now balanced. Okay, here's what I would like for you to try. I have 2 more equations written here, and I'd like for you to try and write those down and see if you can balance them. Put me on pause, and I'll be right here when you get back, and see if you can get these guys balanced. So this is Fe2O3 plus C yields Fe plus CO2, and this one is C3H8 plus O2 yields CO2 plus H2O, okay? So write those down and see if you can figure them out. Put me on pause, and then we'll check them just as soon as you get finished. Okay, how did you do? Were you able to get them balanced? Let's go through and look at this one first. Let's say that I've got 2 irons. This Fe is iron. I have 2 irons on this side. And so if I put a 2 over here, I'll have my irons balanced. I have 3 oxygens on this side, and I have 2 oxygens on this side. Well, in order to add more on that side, I have to have at least a 2 over here, but let me show you a trick on this one. If I have a 3 on one side and a 2 on one side, you can use a trick called least common multiple that you probably learned in math, and you were like, when am I ever going to use this stuff? Well, here's a place where you're going to use least common multiple, because what is the smallest number that both 2 and 3 will go into? Well, it's 6. So if I can get 6 atoms of oxygen on each side, it should make it balanced. So what do I have to multiply 3 by to get 6? Well, I have to multiply it by 2. So if I put a 2 in front of here, and then I put a 3 in front of here, that will give me 6 oxygens on this side and 6 oxygens on this side. Now I have 3 carbons over here, and so that means I'm going to need 3 carbons over here. And so is everything balanced? No, it's not, because I have 4 irons here, and when I initially balanced it, I thought I was going to put a 2 there, but I ended up not putting a 2 there, because now it's turned out that I need a 4, because I have 4 irons on the other side. So if you haven't already figured it out, balancing equations is really a good idea to do with a pencil so that you can always erase something if you make a mistake. Sometimes balancing equations is a lot of trial and error, and so you may write something down and go, oh, no, I'm gonna have to change that. It didn't work after all. It's kind of like putting a puzzle together. Try the piece, it didn't quite work, I gotta try something else. So let's double check this and make sure that everything came out right. 2 times 2 is 4 iron, and I have 4 iron on this side. 2 times 3 is 6 oxygen, and 3 times 2 is 6 oxygen on this side. I have 3 carbons here, and I have 3 carbons here, so I have this one balanced. All right, last one. Again, this is one where you have to be careful because I have oxygen in 2 different places over here. And so a lot of times what it's easier to do is sometimes you want to balance everything else and kind of save that one that appears in 2 places for last. So I'm going to start with the carbon. I have 3 carbons here, and so I'm going to put a 3 over here to balance the carbons. I have 8 hydrogens on this side, and I have 2 over here. So what can I multiply 2 by to get 8? Well, if I put a 4 in front of here, 4 times 2 is 8, and I'll have the same number of hydrogens on each side. So now, how many oxygens am I going to need? Well, I have 2 over here. What have I got on this side? Well, I have 3 times 2 is 6, so I have 6 oxygens here, and I have 4 more over here. So 6 plus 4 makes 10. So I need a total of 10 oxygens on this side, but they come in groups of 2, so how many of these do I need? Well, if I need a total of 10, I'm going to have a 5 there to make 10 on this side. So let's double check everything now. I have 3 carbons and 3 carbons. I have 8 hydrogens, and 4 times 2 is 8 hydrogens. I have 5 times 2 is 10 oxygens, and then here I have 3 times 2 is 6, and then 4 more is 10. 6 plus 4 is 10, so there's 10 oxygens on each side. Okay, so now that one is balanced. Balancing equations just takes practice, and so we're going to be doing quite a bit of practicing the rest of this chapter so that you get really, really good at it. If you have any questions, make sure that you send me an email and ask me.